Hello and welcome to our lesson 2.5. In this lesson, we're working on solving absolute value inequalities. A chapter ago, we solved absolute value equations and we learned some things about absolute values. This whole chapter we've been working on in chapter 2, we've been solving inequalities. So we're going to combine the two ideas together. What's really neat is you already have all the skills to do these problems. I'm just going to help you put together the steps to do it. And so this just builds so nicely. So first thing, remember back when we were solving absolute values equals something, absolute values equal like a number? To do this, we had to break things into two cases. Break into two cases. Well, guess what? If we have an inequality and we break it into two cases, we'll have two inequalities to solve for, okay? Well that sounds very familiar to the last lesson. So if I break an inequality into two cases, and I may have something like this, like 2x plus 3 is less than 5, and I may have 2x plus 3 is greater than negative 5, and wait, if I solve this, whatever it ends up being, I'll have two inequalities, and I know how to put them together if I have a word, either an and or an or between them. This is exactly like the last lesson, and I could do the three-line method we learned to get the final answer. So this just combines the two ideas. We're going to break into two cases, and then we're going to use the three-line method. So the only thing I'm missing is, what word do I use for these? Well, it's quite simple. Let's get a new page. If I have an absolute value, and it is less than or equal to some number, so let's just put some stuff in here. 2x plus 5 is less than 7, or less than or equal to 7. Less thans are always going to give us an and for the word to combine our two inequalities together. If I have an absolute value that is greater than or equal to a number, that's going to be an or. That's the word we use. And the way to figure this out without trying to just straight up memorize it is, it's the second syllable. Whenever you say less than, it sounds kind of like and. Less than or equal to, and. Greater, greater than, or kind of sounds the same. So you look at the original problem, and whatever the inequality is, tells you what word to go with. And then we're able to kind of put everything together. So there's another detail or two I want to discuss, but I want to discuss it within an example so that we can kind of fully soak it in. So let's dive right into an example. Let me give you an example, and we'll see how this all works. So let's go with the absolute value of 2x minus 5, close your absolute value, is less than or equal to 7. So the first thing I want you to do is think about the word. This is a less than or equal to, so that means it is an and. Okay, nice. So now we want to break it into the two cases. And remember when we did these with equal signs, the first case was just to drop the absolute values. 2x minus 5 is less than or equal to 7. Let me make this a little bit neater and bring the and down to this level. And our other case, you still left the left-hand side along, 2x plus 5, or 2x minus 5, and we would turn it into I'm going to write this in another color so it pops, opposite of that, opposite 7, negative 7. Well, there's one problem with inequalities. If I flip a sign, I have to flip an inequality. It was a less than or equal to, so this second case is always going to have the inequality and the sign of that number flip. So there's two things flipping, or you can think of it as a flip and a flop. So this is your flip-flop. Okay? Flip-flop. So you got to change the inequality and the sign. So there's our two cases. Now we should be able to solve each, just like we would if it were an equal sign. I would add 5 to both sides. 2x is less than or equal to 12. Divide by 2 on both sides. And x is less than or equal to 6. And let's solve this one. Add 5 to both sides. 2x is greater than -7 plus 5 is -2. Divide by 2 on both sides, and x is greater than or equal to -1. Nice. So look at what I have. I have two inequalities and a word. Well, I'm not 100% sure what to do with that. Oh, wait, we are. That's exactly what we did last lesson, is I could take these two inequalities, x is less than or equal to 6, and x is greater than or equal to -1, and I could put them together into one compound inequality and write that as an interval notation. Well, how do I do it? I do it with this three-line method thing that we did just last lesson. So this is a great review. The top two lines are just to graph each inequality. So x is less than or equal to 6. So find 6 on this line, less than or equal to 6. Got it. X is greater than or equal to -1. Find -1 greater than or equal to. Got it. And pay attention to the word. We're doing an and. So write and down. And meant overlap, intersection, both. I don't have both on the left. I do have both in the middle. And I don't have both on the right. So the only place I have blue and green graph is in the middle sections. And so you know all this, so I'm going kind of quickly on the three-line method part. Bring down your symbols, since we started and stopped at -1 and 6, and write your interval notation. You're shading from -1 up to +6, square bracket and square bracket. So there's our final answer. So yeah, it took us a little bit of work to get here. We had to solve it, break it in two cases, solve each case, take the two answers and do a three-line method, but you already have all those skills. That's not really that hard. Yeah, it's a lot of writing, but difficulty-wise, not that scary. Let's do another example. Okay, next example. Let's go with absolute value. 3x plus 6, close your absolute value, is greater than 12. So first thing I want to do is think of the word. Greater than means or. And let's write our two cases. First case is always the easy one. 3x plus 6 is greater than 12. The second case, 3x plus 6 is, and we got to do our flip-flop. It was a greater than, it's going to be a less than. It was a 12, it's going to be a -12. Nice. So now I have two cases to solve. Let's solve each case. Subtract 6 from both sides. 3x is greater than 6. Divide by 3 on each side. X is greater than 2. Or solve the other side. Subtract 6, subtract 6. 3x is less than -18. Divide by 3, and x is less than -6. I know I'm going kind of quickly because I know that you can solve, you can divide and subtract and all that. All right, so here's what we have. This is what we're up to. Two inequalities with an or. So I'm going to write them over again and try to do my three-line method. I have x is greater than 2 or x is less than -6. So three-line method this thing. We did this last lesson. See, make sure you put the correct number on the left and the correct number on the right. It is a number line, and -6 is less than 2. So yeah, there we go. Once again, we've been doing this all chapter, so I know you can graph x is greater than 2. And we've been graphing all chapter, so I know you can graph x is less than -6. And then now time for the answer graph, which is an or. Now remember, or is really inviting. Anywhere I have shading up top comes down to the bottom. So I have shading on the left, there will be shading in my answer. I don't have any shading in the middle, so no shading in my answer. I do have shading on the right, so that'll be in my answer. Anywhere that you start or stop a red squiggly shading, grab the symbols from above. And now I can write my interval notation. Now this is that special one with two intervals. The first interval being -infinity up to -6, unioned with, remember that, 2 to infinity. Nice. Awesome, awesome. If I did go fast, pause and think about things and see if you have any questions, but you can slow it down. You can even watch it in slower playback speed if you wanted to on YouTube. All right, let's look at two more examples, but I may not need to work them entirely, or we could work them entirely and we get the same thing. But let's look at the next two examples. Okay, so I want to logic ourselves through these without taking the time to work them, but we could take the time to work them. It would work exactly the same, but if you want to memorize this fact, so I have an absolute value compared to a negative number. The first two examples I did, if I go back and look, were compared to positive numbers. See that? But if I'm compared to a negative number, something weird may happen. Let me talk you through this. This is an absolute value. What's the only thing that comes out of an absolute value? Positive numbers, or zero, but positive numbers, no negatives. So positive numbers, are they ever greater than negative numbers? All the time. So I actually know this one's going to be all real numbers, or negative infinity to positive infinity. So if you ever have an absolute value greater than a negative, that's negative infinity to positive infinity. If you don't believe me, I can work it really quickly for us. We'll break it into two cases. 2x plus 7 is greater than negative 13, or, because it's a greater than, 2x plus 7 is less than, opposite of negative 13 is positive 13. You would just need to solve each of these by subtracting 7. So 2x is greater than negative 10. Divide by 2. X is greater than negative 5. Or, same thing, subtract 7. 2x is less than 6. Divide by 2 on both sides. X is less than 3. Okay, so I'm going kind of quickly because you don't have to do all the work when compared to a negative. I automatically know the answer. So now I'm going to be lazy and just go ahead, instead of rewriting it, do my three-line method right here. Let me scroll down and get a little more paper. Negative 5 and 3. All right. So x is, where's my pen? X is greater than negative 5. Got it. X is less than 3. Change colors again. Got it. And this is an or, right? So anywhere I have shading above comes down. So I have shading on the left. I have some shading in the middle. I have some shading on the top. So looky there, it is the entire number line, negative infinity to positive infinity. So if you want to remember it, does it hurt to remember that, oh, when comparing to a negative, if my absolute value is greater, the answer is negative infinity to it's the whole number line. Or if you don't feel like memorizing it, or you're not sure, because there is the opposite, it could be less than, and then there's a different answer, you can still work it with the same steps. So those steps are brilliant. They're beautiful because they always work. Those steps I've showed you work no matter what. Let's do one more special case like that. Okay? Well, we just did greater than a negative. So what's the case when absolute value is less than a negative? And it doesn't matter if it's equal to or not, but we'll do one with an equal to for fun. Less than negative 20. Well, I happen to know this answer. This is always positive. Are positive numbers ever less than negative numbers? No. So this is going to be a no solution. How do I know that? Well, from what I just said. Well, what if I wasn't convinced? We can still work it because we know the answer and we've done a lot of these examples. I'm going to go very quickly with this one as well. We'll break it into our two cases because it is a less than or equal to. The word is an and this time. And our two cases are 5x minus 10 less than or equal to negative 20, and 5x minus 10 greater than or equal to negative 20. There's our flip-flop, positive 20. Our flip-flop, got to change the inequality and the sign. So we could solve both of these. We could add 10 over, add 10, and that would be 5x is less than or equal to negative 20 plus 10 is negative 10. Divide both sides by 5, and x will be less than or equal to negative 2. And do the other one. Add 10 to both sides, add 10. 5x is greater than or equal to 30. Divide by 5 on each side, and x is greater than or equal to 6. Do the three-line method. Let me scroll down a bit to combine these two inequalities. Let's see, negative 2 and 6. So we'll graph the first one, x is less than or equal to -2. We'll graph the second one, x is greater than or equal to 6. And then we pay attention to the word, and the word we have is and. And only happens to have an answer where these two both are. Do I have both blue and green here? No. Do I have both blue and green in the middle? No. Do I have both blue and green on the right? No, I have nothing in my answer. It is completely empty. It is no solution. So if you have one compared to a negative, you do not have to show any work. You can jump right to the answer. So the two answers are greater than a negative, that's negative infinity to positive infinity. Less than a negative, no solution. If you forget that or are anxious, there's no stress. You can work it, you'll get the same answer. Now, if it's a positive compared to, like this example, compared to a positive number, you have to work it to get the answer. Okay? All right, but I think you can handle these absolute value inequalities. I just love how beautiful it is that it just builds off of everything we've done. You already possess all these skills. You already know how to break into two cases. You already know how to solve inequalities. You already know how to do the three-line method. And in that, you know how to graph inequalities. You know how to get an answer graph and peel off an inequality. So technically, I didn't really teach you much today besides how to put that all together in these big problems. So that's really neat. I love how math builds. That's all I have for you. That's all for Chapter 2, so good luck on the Chapter 2 test, and we'll see you in Chapter 3.